I'm going to talk about Docker security and web simulation tools, how they approach with, and we are going to discuss about how to secure Docker containers and applications that use Docker. Okay. Um, so this is what we are going to be discussing about. We are going to see a brief introduction. We are going to see why to use containers. We are going to comment about the Docker infrastructure and how it works, and then we are going to see how to add security for each component that is used. So first things first, in the last years, container popularity has increased as a solution for server, application, and microservices, providing better performance in comparison with other solutions like virtual machines, or using the host as a server. A container is a software package that contains one or more applications, and all the requirements or libraries needed to execute them. Is a lightweight and isolated package that is ensured to work with independence from the platform where it's being executed, and is used for developing applications or for multiple purposes. It works like a virtual machine, but using the host instead of virtualizing the resources. With container solutions popularity, security concerns has increased too, and container applications have a large attack surface that ranges from the application code itself to the host operating system. Alongside with this increased we will be using Docker as our main example, since we are using Docker for a web project at the university where I work, and we need to ensure that it's properly secured. So why to use containers? Well, containers provide multiple advantages to developers. Some of the main ones are that it brings out a modular design, and it's a scalable development by isolating applications in the containers and providing an interface to communicate with them with the outside world. We have a logical and resource isolation by virtualization of the resources, providing perimeter security and recover capability. And we have portability of the application, since the runtime environment is encapsulated and the container image is easy to share. So we're going to discuss a bit of Docker infrastructure. Docker is composed by three main parts: the Docker client, the Docker host, and the Docker registry. The Docker client will be the client application that communicates with the Docker host using a Docker API. This allows to deploy an environment where the Docker client is separated, is in another computer from the Docker host. And then we have the Docker registry, which stores and distributes Docker images working as a repository. A Docker image is a binary file that includes all of the requirements for running a Docker container. It stores the dependencies, the tools, the libraries, the source code needed for the application or for the service to run. The image works as a template, similar to a snapshot from a virtual machine, but instead of need to use a lot of storage, it's much more lightweight. So hardening on Docker. Well, first things first, what is hardening? Hardening is the process of adding security and reduce security risk. It is a collection of best practices, configuration, techniques, and tools that aims to reduce the attack surface on a system, application, or architecture. And the attack surface is a combination of possible flaws, risks, misconfiguration, and vulnerabilities that you can find on an application, on a service, on a web application, or on anywhere on the internet, really. The process of hardening should follow an order or guideline in order to be effective and cover all the different resources. So, okay, this is a bit broken, but I hope you can see it properly. In this work, the Docker hardening has been built on several levels or layers. The host layer will be the host machine and its operating system, where the Docker daemon is and the containers are running. The application layer deals with the container application and its configuration. The container operative system layer is about the container operative system and the dependencies on security on it. The communication layer will be the layer that manages the networking risk and authentication. And the image and registry layer contemplates the Docker images and Docker Hub repository or whatever repository you're using and its possible issues. Some good practices related to the Docker configuration will be the least privilege principle, that by default containers need root permissions to be run. So a good practice is to add the user to a Docker group and don't have that root permissions. Use only necessary capabilities. Docker allows to remove capabilities to the containers, so use only the essential ones needed for the service. No privilege escalation, which by default containers allow to escalate privileges when required. There are security policies that deny this possibility and should be used on production environment. So if anything happened on the container, it couldn't escalate and get more privileges. The Docker installation files should be secure. It is possible to restrict the file permissions and verify that the owner is only the root user, so they can't change. And whenever possible, the latest software version should be used, since the latest version will have most of the known vulnerabilities patched, so you are more secure. About the application layer, it mainly depends on the application you're running, but whenever possible, latest software versions should be used, since the same thing that we discussed. And if the container image is based on a Linux distribution, it should be hardened accordingly. There are a lot of different guides and automatic tools that you can use to do so. And an interesting approach will be the distroless images that seek to include only the application and the runtime dependencies instead of charging all the usually packages that you will find on a Linux distribution. So it's more secure since you have only the essential things that you need to run your application. And in matters of the operating system layer, we have different tools. One of them is Linux, which is a security architecture that allows to define access controls for the application, processes, and file system. On this example, we can see that Linux is not enabled by default on Docker. So there's a brief example on how to enable. We will change the daemon settings and just restart the Docker systemctl, and that will allow Linux, which will add more security by being in enforcing mode and forcing the security policies. Another thing that we can use is AppArmor, which is another Linux security mode that restrains the access and permission of application. It is similar to Linux. It allows to define different security configuration for each program instead of for the whole operating system, as Linux did. So Docker allows to run containers loading different AppArmor profiles, counting on which application we want to secure. And we can define rules that accept or deny network traffic by the protocol or by the IP. So if we have a blacklist of IPs, we can ban this with this configuration. We can define the directories that are writable or mountable. So we can just allow to write on some directory that we know it is the only one that should be allowed to be writable in the first place. And we can allow or deny certain capabilities, so we don't have privilege escalation or bad call system or things like that. Another tool that we can use is Seccomp, which is a kernel module that provides additional security. It allows to limit the system calls and manage the available call from within the Docker containers to the host kernel. So for example, if the reboot capability is allowed, the system call, from the container, you could reboot the host system. So with a configuration like this, we will block that. This JSON is not saying more that the default action on any system call will be to allow it, but when we make a system call that we do not want to allow on the container, like chmod, for example, so a possible attacker will write a chmod to change the permissions, we are going to block it with this tag action. And about the communication image level, we can say that it is desirable to encrypt the Docker API and communications with TLS or SSH. So we have encrypted communications. It is possible to configure the Docker daemon and client so they have to authenticate each other, and thus adding more security. Regarding the Docker images, Docker Hub most popular image contains multiple vulnerabilities, so choosing an image should be treated carefully. Recently, Docker has included a vulnerability scanning tool that allows to identify potential vulnerabilities in the container images. So it is a tool that you can use to check whether the image you're using has vulnerabilities or not. And additionally, there are external tools which can scan and monitor container images at different stages of deployment. So if you want to ensure that your image has security, you have external tools that can analyze it. And on the conclusions and further work will be that as the use of container and Docker grows, the security concerns are increasing too. It is difficult to maintain an adequate level of security while keeping pace with software updates and its use. And so more research and dissemination should be done on the different hardening techniques in order to increase the average level of safety. And to do this, Future will study more methods and approaches to add security at different layers and levels, as well as performing security verification of container images and related software on real-time protection and integration with security systems. So this will be my whole presentation. Thank you for having me.